So this video will be talking about a conjugate acid base pair. And this concept is really going to become, you'll see, is very tied to the Bronsted-Lowry definition of acids and bases, which we talked about in a previous video. And if you don't remember, what that definition said is that acids are things that donate H pluses and bases H plus donors, we'll say. And bases are H plus acceptors. So if you look back at that video, you'll see that we talked at length about a typical chemistry reaction where you have HCl, which is hydrochloric acid, and ammonia gas, NH3. And on the other side of that we have NH4 plus and Cl minus. And when you look at that video, what we talked about in particular was that the thing that donates an H plus or gives up its H plus or loses its H plus is the acid. So we said, well, HCl has an H, and then on the right it doesn't, right? On the reactant side it's got an H and a Cl. On the other side it just has a Cl. So that means that HCl is losing its H plus, so that makes it an acid. And that means that NH3 must be the base, and we can see that it has one N and 3 H's. It ends up with one N and 4 H's. So what a conjugate acid-base pair is talking about is that your acid-base reactions, this reaction was perfectly fine, except the truth of this reaction is that it's technically a reversible reaction, so it can go both ways. So it should get an arrow like that. And the idea of a conjugate acid-base pair is that what happens to the acid after it gives up its H plus, and what happens to the base after it gains its H plus. That's the idea of a conjugate acid-base pair. So if we look at the other side of the equation, the product side now, so we're over on this side, and if you imagine this reaction going back the other way, right? Well, this is a little bit unorthodox, but we're going to look at it from right to left here. So we're going to be looking that way, right to left. And if you look from right to the left, you see that the NH4 plus had one N and 4 H's, and then if it goes from right to left, it lost its H plus. So that means that this thing is kind of an acid. And then the Cl did something similar, right? The Cl minus went from Cl minus to HCl if we're going from right to left. So the Cl minus was kind of a base. And that's important, right? That's really the idea of a conjugate acid-base pair, is that acid bases happen in reversible reactions. So when you have an acid-base reaction, the acid loses its H plus, and really what it does is it turns into a base on the other side. Now, to help designate it, that it's paired with, that this Cl minus is paired with this HCl, we use a special term. We don't just call it a base. This also helps eliminate confusion because we already called the NH3 the base, right? So after your acid loses its H plus and becomes Cl minus, we say that it turns into the conjugate base, and we do the same thing with the NH3, NH4. After NH3 gains its H plus, it now has an extra H plus. It's going to give it up if it's going the opposite direction. We would call this the conjugate acid. So in summary here, when you're talking about acid-base reactions, they're all going to be reversible, or most of them are reversible, so you'll see those double arrows. And if you see those double arrows in the middle, that means that, yeah, there's an acid and a base on the left, but on the right there needs to be a conjugate acid and a conjugate base. And just kind of a good summary here, your acids turn into conjugate bases on the other side of the reaction, and your bases, they turn into conjugate acids. So it kind of flip-flops. And if you think about it, it makes sense why it flip-flops, right? If my acid is HCl and it gives up its H plus, and now it's Cl minus on the other side, how can it possibly still exist as an acid? It doesn't have an H plus to give up anymore. Same idea with the NH3. we've got NH3, one N, 3 H's, it's a base, it accepts an H+. Now look at what it has. Now it has an extra H+ over there. It's going to want to get rid of that before it takes on a new one, so that's why it becomes the conjugate acid. So acids turn into conjugate bases, bases turn into conjugate acids. Your acid-base conjugate pair is just a way of talking about the reversing of these acid-base reactions. Because they are reversible, you have to observe conjugate acid-base pairs.